This day 10 of the Data Science Bootcamp. In the previous lecture, we started with SQL, and in this lecture, we will be continuing by understanding different concepts of the SQL. Devesh, if you can share your screen and open SQL board, we'll get started from there. Devesh, are you familiar with all the SQL's command? I believe you had workspace installed on your system. Workbench, my bad.
Yeah, like basics I have.
Basic, right? Okay, cool. Okay, did you go through it? Were you able to solve the previous problems in the SQL board? Devesh, I'm asking you. We lost it. Yes, you shared your screen and we lost it. Krish, if you can share your screen. Am I audible?
Okay. Yeah. Let me share it. He's having some trouble, I think.
Yes.
Is it visible?
Yeah, it is visible. Can I? No. Let me remove it from the screen is not visible. No, it's fine. Cool. So, till how many lessons did we complete?
Up to queries with aggregates. The
Aggregate.
last
Did we
we did
complete that?
was okay. From lesson 9 we are in.
Okay. Okay, cool. Let's go through it together. Did we finish lesson 8?
No, we were. Yeah, no. We have not finished. We will start from lesson 9 in today's class.
No, lesson 8. Like, did we finish it?
Yeah,
Talk about
8
we did, right?
we finished. Yeah, 8 we finished.
Cool. Let's start with lesson number 9. Okay. In addition to querying and referencing raw column data with SQL, you can also use expression to write more complex logic on column values in query. This expression can use mathematical and string function along with basic arithmetic to transform values when query is executed, as shown in this quizzes example. As you can see, what we are doing, we are selecting a column, dividing it by 2, and naming it as half a particle speed from physics data. And that is one of the operations that we are using. We are using an absolute function, and we are making sure that after putting into absolute multiplying by 10, the speed should be greater than 500. Okay. So there are different kinds of database. SQL is one of them. PSQL, PostgreSQL, which is mostly used because it's open source. Don't have to pay for it. So it does support multiple mathematical function. Cool. Let's get started. I think this should be easy. Do you want to revise, join? Do you want to go through any problems that sort of does
No.
join?
No.
Good, right?
It will be okay.
Okay, cool, awesome. I'll open that on my screen as well. Where is the expression? Cool. List all the movies and their combined sales in millions of dollars. Cool. So this will involve a mathematical function.
And their combined sales. Millions
Combined.
of dollars. Okay. Combined sales means domestic plus international sales, right?
Exactly.
And listing all movies. So we need to join the table, I guess. Okay, so we can.
Have you used ORM by any chance? Object relational mapper.
Yeah, I have used a few times.
What have you used?
Mainly in college project I used for Java, but right now I don't remember. And for
But what did you use exactly? Okay, so there are certain ORMs available. Django has its inbuilt ORM. SQL Alchemy is one of the famous ORMs.
Yeah.
Okay, cool. So mostly this is for data science, you'll be using this, but when you use built applications, ORMs are something that you will use. Cool. We'll get into depth later. Let's start this. Devesh, are you back?
Yes, I am joining with the phone.
Okay, cool. Leave it. Krish will share the laptop screen and we'll do it from there.
Okay, so should I stop or should I continue?
No. You do it. I said like you will share the laptop screen and do it.
Is it visible, right, my screen?
Yeah, it is visible. Let's get started. Like
So
it's a
let's
combined
start
sales
with,
of domestic and international. Make a join and list it.
okay, so let me quickly see the join queries. Okay.
Hmm.
We should do the inner join. It will work, I guess.
Yeah, we want movies and their collective sales. So left join is also fine and inner join is good, like whatever. It's
Inner
good for
join
you.
box office.
Movie spelling is wrong. Nishant voted and did not join.
Okay, right?
Yeah, right. Okay, the join is
But
good.
now when
Now we
we
want
combine sell off,
movie name, right? We need name
hmm,
and the combined sales.
so first of all, it will be title
Column name. Yeah, sorry. That's right. Yeah. I mean, I
and
said movie.
domestic
Mhm.
sales plus international sales.
Yes.
Right, like this. So
That is correct. Okay. Finish the query as combined sales. Total sales, yeah. Okay, it's still not done yet. It is in number, and we have to convert that into millions of dollars. So that would be divided by 10 raised to 6, and we would be good.
this is whole divided by 10 raised to 6.
Yes, that's million, right? Million is 10 raised to 6. And don't do that. I mean, you're doing making operation in domestic plus international. So just write it over there. That should be it.
Here.
Yeah,
Okay.
done, right? Cool. Let's see the solution. What is the solution? You already saved it, so you won't be able to. No, don't do that. Don't do that.
So
Um,
my table. Let me again.
refresh it. Let's see their solution. What exactly what we did. Cool. So in that column, you can perform mathematical operation, and you have to name that column as like this is the new column name. Got it. Devesh, any doubt here? No, right? Can you hear me? Oh, why am I doing this? Can you hear me? Okay, cool.
Yes.
Cool, Chris. Let's move ahead. List all movies and the ratings in percentage.
Install movies. 20. So let's start from movies and the ratings in person. So let
Ratings are again, it's a join.
me is join. Select select all movies and the ratings in person.
Mhm. The ratings are out of 10.
Hmm.
It has to be out of 100.
So we can do here, or is there any?
No, do it right there. So multiplying the values of the column, so you make operations in the column. So it would be title, comma rating into 10 as rating percentage. Title, rating into 10. And what would you name it?
Why it is done like
So it is taking your expression as the column name because you are not putting S. Rating as rating percent, let's put whatever you want to. Okay. Now put into 10. See, this is out of 10. We want it out of 100. So we are multiplying by 10. That's it.
okay, yeah, got it.
Got it, right? Divesh, did you get it?
Yes.
Oh, cool. Let's move to the next lecture. Next problem. List all movies that were released on even number of years. This is also another operation. So operations you make in columns. Okay.
So though we
You
did
know,
not join here, I guess, because we have years in this only.
cool. Yep. Okay.
Table. Directly we can say we can do module will work.
Modular will definitely work. It's an expression, right? So the operation is done. But to put an expression. Oh, okay.
Will return 0 or 1.
Hey, you can do a where. That would be better. That in where clause. Where like even year is percentage equal to 0. No, to do it in column.
Where?
Yeah.
Here.
See, it is asking us to list all the movies that were released in even year. So it's a query. There's no operation here.
Okay.
Where percentage, the condition that you percentage equal to 0. Yeah, that's it. Got it, right? The difference. See the solution. What's the solution? Yeah, exactly our solution. When you're filtering a column, let's say you need a different expression. We manipulated the data to make changes in the column. When you want to query in the column, you use where. Like where can I find this? So got it, right?
Yeah, got it.
Okay, continue. Okay, this is something more useful. And as a part of being a data scientist, this is what you will be using more. Okay, let's go through it. In addition to simple expression that we introduced in last SQL, also support use of aggregate function, a function that allows you to summarize information about a group of rows or data. With the Pixar database that you have been using, aggregate function can be used to answer question, how many movies has Pixar produced? What is the highest grossing Pixar film each year? So in the aggregate function, we have to pass an expression, similarly what we did, and whatever the constant that you're putting. If you go to the constant, then you'll have more idea. Let's say there's a count function if you're familiar. There's a min function, there's a max function, there's an average, there's a sum. Okay. So these are the functions. These are self-explanatory. Let's say if you want to find the count, you get the count, sum, and sum. You can also group your aggregate function. You will get a better understanding when we write queries. So let's say there is a constant that you have put and you want to group by it. Let's say how many, what do I say? Employees are in building A, building B. So you're grouping towards a column. Okay, let's get started. Going to our employee table, notice how rows and table have shared data, which will give us an opportunity aggregate function to summarize some high-level metrics about the things. Okay, find the longest time that an employee has been at studio. Okay, so there's an employee, and the longest time they have been at the studio is going to be years. Find the longest time that an employee has been at the studio. Got it.
We can use
max. Sorry?
Max operation, I guess.
Yes, we can use a max, but it is, are they asking that? Okay, let's get started. We'll try to solve it and then we will solve it. Mhm. Yep, Scott has spent the most time. Okay, Devesh, you try to solve the next one. For each role, find average number of years employed by the employees in that role. When there's an each, use a group by.
Group, yeah.
Are you able to solve it, Devesh?
I'm trying.
Okay. Okay, let me know when done, Devesh. Devesh.
Not that.
Okay, cool. You can look into the screen. So first understand the problem statement that for each role, when you see the word each, you use group by. Like you have to group by role. So that's a keyword. Find average number of years employed by the employees in the role. So we want to find the average. Like if an artist is spending 6 years in this company, like that is the average year of that employer. An engineer is 3.4, a manager is 6. So how you are doing? There's an aggregate function. The aggregate function is average. But if you use a group by, then it will be for each particular data in that particular row. But if you don't use a group by, you'll get a single value. You're getting it? So that is how you're solving it. You're selecting, we are getting the role column. Then we are getting the average employee. If you remove the group by, it will only show you one detail. Then you have to group by the role. So you get all the details. Like it is set to each role. Got it? Okay, cool. Let's move to next lecture. Next problem. Find total number of employee years worked in each building. Okay, how do you do that? How do you do it? Find total number of employees years worked in each building. Okay, again, each building is the keyword. Krish, you are now getting like how things are working. So anything you hear in English, you would be able to convert into an SQL query. So that is something. So whenever there's a problem statement, you or your manager is telling you that this is what we want. Instantly in your head, you should be able to frame queries. Let's say it's an each, use group by aggregate. These are the functions. Joins is something that we have to take a look at. I think joins are easy. It's not hard, but
Yeah,
maybe
joins are easy.
initially you find it difficult, but actually you have to work with joins because joins are the most efficient way you store a data. That's a beauty of relational database. Cool.
Normalization is the thing.
Yep. Devesh, are you able to understand this query? School, right? There's a building. We are getting sum of the years. That's exactly what has been asked. And we are grouping it by building. And we are getting a building and total number of years, the sum of the years in the building. Cool. Let's continue to the next. Again, it's part 2. Let's start with the exercise. Okay, there's a having clause. Okay, scroll up, scroll up. I think they are, okay. What is a having clause? Our queries are getting fairly complex, but we have nearly introduced the all important part of select query. One thing that you might have noticed is that group by clause is executed after the where clause, which filters the row which are to be grouped. And how exactly do we filter grouped rows? Luckily, SQL allows us to do this by adding an additional having clause, which is used specifically with the group by clause. Okay, got it. Select as a group by column, you run an aggregate function from where condition group by with a having. Okay, having clause constant are written the same way where clause constant are written are applied on the grouping group rows. With our example, you might not seem like particularly useful construct, but imagine having millions of data with proper properties. Being able to apply condition is often necessary to make, okay, whatever the group row you want to provide a condition, there you use the having clause. If you aren't using group by clause, a simple where clauses suffice. Did you guys understood this? When to use having clause?
Yeah.
Okay, Devesh, did you? Did we lose him? I think we lost him.
So, sorry, sir.
Oh, you're there. Okay, okay. So did you understand where we have to use having clause?
Like it's work like a like where condition. Like
Yeah, but on the group by columns. Got it? Hello?
yes, sir.
Got it, right? Okay, cool. Let's get started. Find number of artists in the studio without a having clause. Find the number of artists. Count. But the artist, okay?
Artist, that means either it
The
be
artist, right? You filter the role.
okay.
No, this will not work. We just want number of artists. We don't want number of engineers, number of managers.
So like we have total of 14 artists. So it is
No, we have engineers, we have other professions, and we have artists. So number of artists is just
okay,
5, I
okay.
believe.
Only artists. So where we are
Yeah,
just
put a where. Cool.
I don't think we need this operation now.
No, we need count, right? Count is needed. We need number of artists.
We got it. Got it. We need total of how many artists are there.
Yeah. In this case, you should use star because we don't. I'm not specifying any column name. So cool. Okay.
What does count star do? Like
All the columns counts all the
okay.
columns. If you are specifying a single column,
Mhm. Okay.
okay, mostly should have been count role or count. I mean, because you are making query on the role. If you want to use a having clause, it has to be select star from employees. What was it? A number of artists in studio. Okay, count role from employees Then if you have to do a group by artist, and then having role equal to artist, because
If we have
because we are using group by.
group by.
But we are not using group by. I mean, we should not use group by. It's not needed. We'll just simply use a vary clause. Okay. Find number of employees of each role in studio. Easy.
Yeah, that's
Divesh, are you following?
My laptop is now shut down. I will be joining with
Okay,
data.
cool. Each is the keyword. You got it right. Number of employees in each role of the studio. Cool. Find total number of years employed by all engineers.
something we
Total
did with
is an
the
aggregate.
artist. Yeah. So total, or we can use sum also.
Some. Sorry. I made a mistake. The one you made previously. Like engineer is a role. You also thought like role is artist, right?
Yeah.
The column name is artist. Yeah.
Sum of the-
It's total. We only want for engineers.
We have to use where.
Yeah, we only want single value.
Okay.
It's cool. Done. Let's move to. We have three Devesh. Yeah, there are three Devesh. Nice. You're increasing my head count. Cool. Continue. Now the order of execution. This is very important. Okay. As in mathematics, there is BODMAS, bracket, opposite bracket, division, multiplication, addition, and subtraction. That is the order. Similarly, SQL also has their order. Now that we have an idea of all part of the query, we can talk about how all fit together in context. We have a distinct, we are running aggregate function, then we are doing a join, there's a where, there's a group by, there's a having, there's an order, there's limit. Okay. Now the order of execution. Okay, let's start with this. Okay. The from clause and the subsequent joins are first executed to determine the total working set of the data. Okay. So always remember after the from, wherever you are making the join, that is where the order of execution starts. So it will first create a database of all the tables as per the joins. Then the order is where. The where constraint is applied. Okay. The query is done. After that group by, scroll down, it groups. After that having, after that select, after distinct. So sometimes it can happen. Let's say you're putting a where and having function, but your having is overwriting the where is overwriting having condition. So then you have to remember that is the order correct.
Okay.
Okay. Cool. Let's go one by one. Scroll up. Okay. Having after that select expression like which column we have to select. Scroll up, Krish. Let's go to the order once and then we'll get started.
Scroll up. Okay.
Okay. From join, then where condition. Okay. We are creating a table, then we are running the where condition. Scroll down. Okay. Then there's a group by. Group by the next order is having. After that, it selects the column. Then if there are any distinct rows that you have to work on, that is the order. And then it is order by, which is like what should be the ascending order. And then it is limit and offset. The order actually does make sense. Like if you want to query something, this is exactly how you would query. Okay, let's understand the problem and let's get started with it. Find number of movies each director has directed.
Each director is directed from
Find number of movies each director has directed. Uh,
you
Number
can
of
group
movies,
by
that's an
the
aggregate
director.
function. Each director is a group by.
And on the
Okay.
title,
If you
like
want number of movies, sorry,
can we can count the ID, not the ID, but
count the director itself, right?
hmm,
Every movie is, what do I say? That's it. You're getting it. You see, there's a number of movies. It's an aggregate function. Then each director, it's a group by function. So that's how you do it. Cool. Find the total domestic and international sales that can be attributed to each director. Again,
director. But now we have to use the joins to
you have to join it. I'll tell you a story. So when I got started, we had an intern in our team, and I assigned him some tasks. So he was not familiar with joins. So what he did, he wrote an ORM, and then he wrote a for loop after it. They would like compare if movie ID equal to this, movie ID equal to that. So that would have been a very inefficient solution to the getting what I'm saying. Okay, let's start with John. He's a very good engineer now. It's been a while.
Mhm. And what is director?
Just a second, guys. I think there's a problem with my internet connection. The screen has frozen for me. Just give me a minute. I'm back. Am I audible?
Yeah.
Okay. Find total domestic and international. Okay, if it is sum, it's total sales, and it's a join on table, and we are grouping by director. Okay, simple. Any questions, Devesh, Krish, anybody on this? No, right? Okay, let's write our own query. I mean, show me the table. Go back. Okay, these are the table. I'll give a query. Okay, the query is I want how are rating proportional to length of minutes. You know, a movie rating
Hmm.
and length. That's what I am trying to suggest is I want to understand, does it affect the rating? Let's say if the rating is more, does it tend to have less uh, time or something like that? Let's say if the time is more, the rating is more. Like how do
Mhm.
you do it?
Okay. We have to
So
see the
what,
relation.
yeah, the relation. So what I'm expecting the output should be, uh, maybe provide me the title name, length of time, and rating, and sorted by rating. Yeah, just sorted by rating, and so we will understand by. I think yeah, that should be it. It's a very simple problem. Okay, sorted by rating,
We
sorted by
order by
the maximum rating should be at the top.
order by rating.
Okay, now the length of the movie should be greater than 90
Okay. Now we want,
to a greater than 100 to a length of the movie greater than 100.
so it will be after or before the order by, where we have to
It
use the
should
where
be
clause.
before order by. The where clause has to be right after you make the join. Okay. Uh, okay. Now limit up to 5.
Mhm. I
Okay. We have a limit up to 5. Now I want total box office collection of this as well.
okay. Box office collection, domestic, international, both.
Uh, okay. Now what I want a query where the international sales is greater than the domestic sales by 20%, at least 20%.
Okay. So we have to use in the where clause only, right?
Mhm.
But like uh, within this clause only, or and we can use and operator.
Yes, we can use AND operator.
And domestic sales.
Where let's say domestic sale, I mean international sale. Uh, yeah, international sale is always greater, I believe. So international sale is only greater by 20%. If it is greater than 20%, that I don't want to see it.
Greater than domestic sales.
Yeah, all international sales are greater than domestic sales, as I can see through my eye. So
Hmm.
I only want which are more than only more. I mean, in a margin of 20%. If it is more than 20%, I don't want to see it in the table.
Okay, so then we have to, I think, use the operation in, we can use here or not. I'm not sure.
Let's try it. It's more trial and error. Once you make mistake, you will remember it for a longer time.
20%, right? So into 20 by 100, something like this.
0.2.
Won't make sense, I guess.
So it has to be domestic sales plus domestic sales multiplied by 0.2. And it has to be lesser than. So let's say domestic sale is 100 and international sale is 110. So our constraint is that it should be less than 20% of domestic sale. So then it fits in there. If it is 130, it does not fit into our query. Devesh, did you get the problem statement?
So domestic sale should be greater than international sale by 20%.
Yeah, only by 20%. I mean less than 20%. So everything will be included.
So does this work or not?
It will not work because see, what you're doing, only 20% of domestic sales you're putting. So what we have to put is domestic sale plus domestic sales into 0.2. So that means we have, what do I say, 20%. We are showing the 20% value more, if you're understanding what I'm saying. Like think
Like
with a
this.
query. Yeah, correct the spelling, like domestic, it is written. Domestic sales plus domestic sales into 20%. Yeah, exactly. That's the query.
Okay.
So here, assume the domestic sale is 100 and the international sale is 110. Then this query will satisfy what we are doing. 100 plus 20% of 100 is 120.
120.
So international sale is less than 120.
Mhm.
Then we are sufficing the query. And the length of the movie is 100. The rating is good. So all that. Got it.
Okay.
Okay. So while you are writing query, you will not immediately have this problem statement in your head. While you are going ahead, you have to think of query. Maybe I'll put this query, then I'll narrow it down. I'll put this query, then I'll narrow it down. So that how things would work. Okay. Any questions, Devesh? All right, Krish. Any question? Okay. Do it with an in operator.
In operator.
What I want film that are created by this director. Scroll up. John Lannister, Pete Doctor, and Brad Bird. That's a new query.
Okay. So what do we want here?
I want movies directed by John Lasseter, Andrew Stanton, or Brad Bird. Pick any of three.
Okay.
Okay. Do it with a where clause, of course. It has to be in quotes. Cool. That's the in operator. So if you want to do it in where, like you have to write multiple condition, director equal to John Lannister, director will be there. This is one of the operators. We did come across this, right?
Yeah, in the first or second part, it
Okay,
was
cool.
there.
Okay, that is it. Let's move to next exercise. Devesh, are you following along? Okay, cool. Now this is inserting rows. Go back. One of the important aspect in the database is insert the row. Okay, I believe you guys must be familiar what is a schema, so we'll just skim through it. We previously described a table in database, a two-dimensional set of rows and columns, with the columns being properties and the rows being instance of entity in table. In SQL, the database schema is what describes the structure of each table and data types that each column of the table that contains. For example, in our movie table, the values in the year column must be integer and the values in the title column must be string. Okay, that's the schema. Schema is the skeleton of the database, as you all know, specifying a 2D table. What would be the value of the column? What would be the value of the type of the column. All of that are decided in scheme. Okay. How do you exactly insert a data into table? So that's an insert into table. Then you provide a value, and this is how you do it. So that's one of the way to do it. And some easier cases where it would work, you can provide this column name once, and you can provide the value. Okay, what's the difference? Let's say insert into table column, another column, insert into table.
In specific.
Okay. For specific column, that's the difference. Okay, scroll down. Insert movie ID, rating, sales and millions, and all that. We already covered this on in the previous lecture. Let's not do it. Let's skip this. Okay, updating a row, we also covered it in the previous lecture. We want to update a column, let's say whatever you want to update, but you have to provide a condition.
Set.
Update column, you provide a set. Okay, scroll down. Okay, let's solve this. Okay, let's solve this exercise.
Okay.
The director for A Big's Life is incorrect. It was actually directed by John Lasseter. Okay, let's try to fix it.
So this is set operator. It works on column, right? So we want to change the title.
Director.
Oh, sorry.
You want to say director, right?
We want to set director equal to
John Lasseter.
John Lester. Okay.
Oh, it's Lester. Must be an English character.
And where clause we will use title equal to this.
Bug's Life. Awesome. What did we miss?
Let's see. Will it work or not?
Should work. What are we missing? Set. It worked, right? What happened? Did you miss anything? It did not work previously, right? Did you change it?
No. It worked only, but I didn't click on the run query.
Oh,
the first
okay.
time.
Okay, the year that Toy Story 2 was released in is incorrect, was actually same.
Yeah, it is. Take the
Table in his movies. You want to set
year. Oh, my bad. And we are setting the year. Equal to 1999.
where the title is Toy Story 2. Cool. Okay. Both the title and director for Toy Story is incorrect. The title should be Toy Story 3 and it was directed by Lee Unkrich. Cool. We have to update 2 columns now.
Set column which title and director, right?
Title equal to no.
It won't work.
Title equal to there you put the value.
Title should be
It is Toy Story, what it is, 3. Then enter another column. No, comma, another column.
okay. Another column is director.
Okay. Where do you want to update it? See, if you run update, it will update everything. So that's the tricky part. Where title is Toy Story 8.
Yeah.
Let's move to the next. Deleting a row again, delete with where condition. Okay, let's skip this. Let's not do it. Hardly will delete anything. Just remember, like if you want to delete a column, you just put a condition and it will delete the whole. Sorry, my bad. Row. You want to delete a row, you delete a condition, it will remove all the what do I say? Data. Okay. I think it's a two exercise. Let's finish it quickly. Okay, let's remove all the movies that were released before 2005.
Where
Mm-hmm. Yep, you're right. No, 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 no. Yeah, cool. All the movies that were released before 2005 are deleted. Andrew Stanton has left the studio, so please remove him. All the directors, all the movies directed by him.
that's same.
Devesh, are you at lesson number 15? Right? Okay. Any questions anywhere you want us to stop? Just let me know. It's cool. Now, how do you create a table? Okay. Create table, table name, and you have to provide the column. That's the basic type. And other better way to do it is create table if not exist. Because if you, I mean, if table already exists, it does not create table. But if it exists, if it does not exist, it creates a table. So this is the command that we use. Okay, scroll down. I believe you guys are familiar with the data type, so let's not go into it. Okay, scroll down.
What is this?
Blob is a type. Let's say if there's an images or anything, you put it there.
Oh,
Usually we don't use blob. What do we use? We use either an S3 bucket or an Azure blob storage. Then we
yeah.
put all the metadata and the URL and the link are put here. Don't want to burden your database. Because at the time of development, a database makes a multiple copy. Dev database, easy in prod environment, depends on the SDLC that the company follows. So we try to make it as efficient as we can. The table constraint, primary key, auto increment, unique, not null, check. Check is an expression. Foreign key is where you uh, show the relationship to the table, where you define the relationship. Okay. Not going into depth. I am expecting that you guys must be understanding all of this. If there's a doubt, let me know. I'll go in depth. Here's an example for the movies table that we have been using the lesson up to now, and indexes we have to create a table. Okay. Now create a table named database with the following.
Here, table name database.
Hmm.
As name.
There's a name, this version, and download count. No, version is float and download count is integer.
Right.
Suppose they should do it. Okay. We can specify constraint. There are no primary keys here. So what this table will do, it will create a column ID and that will be the primary key. Let's say if you want to specify primary key to different what was entity, you can definitely do that. There's a certain constraint you want to provide. Let's say the version name. I mean, not a right. Let's say name. You want the name to be unique.
Hmm.
So there won't be any other row with the name value as SQLite or as Postgres. So
Yeah.
all those constraints you can put.
Now, where do we use the check expression?
More like that. Let's say if you want to, what do I say? The string should have the word SQL in it. So that is how you put check constraint. I think let me show you an example on check. That would be beneficial. Okay. Check constraint. What we'll do, I'm sharing my screen. Okay. As you can see, we want to put a check. We are creating a table. Table is person. The ID it has this. It is also constant. It can't be null. The last name can't be null. First name you can put it empty. The table will only take insert operation if the age is greater than or equal to 18. Okay.
Mhm.
So that is how you provide check. We are using MySQL, so this is how we provide it. Every other table has their own way to put it, but usually you would be able to do it. You know, there is a constant check person. This is how you do it. Okay. So let's say while you are designing a table, you are already sure that this is how I'm going to take the data. You provide a check constraint. Can't stop presenting. Okay. Krish, if you can start sharing your screen again. Let's go to next. We want to alter table. Okay. I mean, anytime you make a table or do any data, there are going to be changes. Let's say you haven't foreseen a condition where you have to now add a table or delete a table or make any changes. So you can alter the table.
Mm.
Okay, how do you alter the table? You do a alter table name. Either you want to add a column, you put add with a constraint. You want to drop a column, use a drop. You want to rename a table, that also you can do that. Okay, cool. Cool. Let's scroll down and let's finish this. We want to change the table. So it will be alter table movies.
To add
You want to
column.
add a column. Yep. Add column aspect ratio.
Data type float.
It will be in this thing, circular bracket. Okay, data type you can put it right. It has to be, what's the data type? It's float, right? In our case.
Mhm. So we definitely this. We have float.
Is that it? No, 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 no. Just put float. I think that should be. Do we have to specify data type?
No, 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 no. It
Okay.
will be generally this float.
Yeah, let's run the query. It's cool. Add another column, language with text data type to store language that movies will released and ensure that the default for this language is English. Yeah, that's it. Paste the same query, but this time we will be adding language column.
Filter table movies. Add
Yep, add language, data type text.
text.
Yeah, and constant. How do you provide a constant? Scroll up, we'll check it. The default is English. Okay, default value is English. That's it. Scroll down. Default in braces and in what is it called? Quotes English.
So we need to write the default word or
Yes, 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 yes. You have to write default
Mhm.
and in quotes write English. Yeah, that should be it.
Oh, so it's
Cool.
value is English. Right.
Got it right. All the default value will be set to English. If it is empty, it will be set to English.
Mhm.
Yeah, because we are creating a new column, so it will be English.
That's
Dropping table, drop table name. If the table exists, you drop it. Let's finish this quickly. Scroll down. The table name is movies. Yep. Let's drop box office. And we are good. Continue. Yep, you have finished your tutorial. Now, at least you both have basic knowledge of SQL. enough to understand a query, write a query. There are so many other things that we have to understand. We can write our own sub-function. We can write our subqueries. We can use this. I mean, how we can try reuse an SQL query. All of this we would be learning. That is something we will learn in depth in the next lecture. But for now, let's finish a few things which are pending. Just give me 1 minute. Okay, now I'll start sharing my screen. Just give me 1 minute. We'll keep SQL basic for today. From next lecture, we'll start with the advanced SQL. Just a second, my screen is not loading. Give me a minute. I'm setting up my system. Next, we are going to learn transactions, auto commit, and then we will keep the lecture till then. What are views? What is a stored procedure? What are indexes? There's no problem with the meeting, but rest is running slow. When I want to download a document, it's taking a lot longer. Okay, while it is loading, I'll just give an overview. What are views? Any idea what are views in SQL?
Views.
Views, yeah. Hello, am I audible?
Yeah, yeah.
No idea, right?
No.
So views are not table. So they are, let's say you've written a query and you want to save it as a separate table. Then you want to make a query out of it. So you store it as a view. They are not essentially table, but they are views. They are a table created out of a query. Similarly, there are stored procedures, which are functions you write in SQL and you can use it. Let's say I've written a function which checks each of the people. Every time I don't want to, not check, I mean, check if let's say I have written a constraint where the age has to be certain, the date has to be certain, or you're getting my point. I don't want to write the queries again and again. Reduce repeatability, you use stored procedure for that. So that's one of the things. And the other thing is indexing. Indexing is a very important concept. Any idea if you guys have worked on a non-relational database like Elasticsearch or anything?
Yeah, not properly used, but I have a little bit of idea of indexing for fast searching.
Yes, exactly. Fast query indexes does help. If you want to index a column, you can, if you're seeing that this column is something that is particularly being used and there are millions and billions of records, indexing that
Yeah.
column will fetch you faster result. So that's SQL does something in behind the scene. They create I forgot which tree they exactly create, but they created different data structure behind the scene so that the query is fast. Okay. Similarly, when you have it, my God. Yeah, let's do one thing. Give me 5 minutes. I'll get the document and we'll join that. Okay, maybe at least I'll leave because it's affecting my bandwidth. So I'll join in a few minutes after I get my document. So it will be a small 20-25 minutes lecture, and then we will get back in the next step. Okay, see you in 5 minutes.
Okay. Sure.
Yes, I'm back. As soon as I closed the meeting, I was able to download the document. There is this popular YouTuber, Score with Harry, if you guys are familiar. So he has this very good handbook.
Okay. Yeah, go with Harry.
Yeah, I think creating done. What is MySQL done? Mm, common constant. Modifying table done. Renaming column done. Dropping a column done. Inserting done. How to delete done. Comparison this thing done. How to delete data done. Delete specific row done. Okay. Deleting specific row using where condition done. Okay. Auto commit and rollback. This is I want to take a look at. It is one of the. Any idea what auto commit is? What is commit? What is rollback?
Yeah.
That's right. Okay, cool. Do you want to explain it or shall we go ahead directly?
I have a little bit of idea like writing the queries and we use the keyword rollback and commit. So from that point, our query just gets rolled back to the earlier point.
That is very necessary. Let's say while we are making a transaction and you make the payment through your
Yeah.
ReserPay API, there are certain updates happening in the table, but the transaction has to be invalid. So you don't put it in the table. So you start with initial values in the table, you store it. You set an auto commit. Okay. Commit is set to 0. Enable commit set is 1 to 1. Now what we are committing, let's take an example. I have added an item to my cart. Okay, let's not focus on this example. Let's focus on our example. I have added an item into my cart. Then I am making a payment, but the payment failed. So all those details will be again rollback. So if it is done, you put a commit. If it is failed, then you put a rollback. And when you put a rollback, then nothing is stored in our main database. Let's say, or else like order would be delivered automatically. If you're getting my point. So automatically commits every query, which is set to auto commit is already set for every query. You are running any query, insert, update, delete. Okay. So these are automatic. So you write a query, it is done. If you set a auto commit to 0, it disables the commit. It will only save all the changes in a transaction. You start a transaction here by using the transaction keyword. You start a transaction. You make changes in the table. And if you're satisfied with the changes, if you put a commit, then only the transaction would be successful. The set of queries will be performed and the changes will be reflected in the database. If there's an error occur or if you don't want to do it, then you use a rollback keyword and it rolls back. Okay. Any doubt here? No, right? Usually when we have to perform such things, we don't do it in database. We use ORMs because ORMs handles it really well. The transactions, the commit. That's why I was asking if you guys have used ORMs because there are certain transactions you only want to commit after a level of transaction is done. Like making payment, buying objects is one of the examples. Okay. Similarly, okay. Always use transaction when performing multiple related operations. Disable auto commit when working with critical data updates. Roll back if in any step if your transaction fails. Test your transaction thoroughly before running them into production data. Okay, cool. I'll share the notebook. I mean the PDF file for you guys. Again, the next one is getting current date and time. Now, MySQL provides built-in function to retrieve current date, time, and timestamp. These are commonly used in data logging, time-based queries, and tracking record in data science. So whenever I create a database, there is one column always present is updated and created. So it helps me like when the data was created and the data was updated. And this is current date is a function which helps you get the current date, whatever is the current date. The current time helps you get a function, whatever is the current time. And this is how you get it. If you want to, we set the default date is current date plus current time. Mostly it is timestamp. Current timestamp is set to. So whenever I'm designing a table, there's a create table. The default value is set to current timestamp or select.now. So this will give you the current date, whatever the exact time right now is. So let's say in a database, an entry was made at this time. The update also would be same because we are putting default by that. But every time there's an update, we want the update column to be updated with the current time. So we can use this particular function to achieve that. Okay. Now current timestamp will give you the UTC time. The local time will give you the local time, which is in our case will be GMT 30. Okay, the local int refers to time zone configured on the MySQL server, not the user system. So wherever your server is, let's say if your server is in Mumbai or Indian server, the GMT would be configured accordingly. But your users are making commits from East Coast or somewhere from Europe, their timestamp won't be reflected. So usually, I mean, when we are dealing with multiple clients, we save everything in UTC time zone, and we show it on the front end based on their time zone set on the system. Okay, using in table inserts, date and functions, recap, current date, time. Cool, cool. Deep dive into constraint. Yeah, the constraint that we have already not null. We want the columns which are not null. That is what we want to save. Unique constraint, we also went over it. Default constraint we have used. Check constraint we have checked. Naming constraint. You can give explicit names to constraint. Okay, that makes them easier to reference, especially when altering or dropping later. So what we are doing, we are creating a table, age integer constraint. Check age is the constraint name, where check age is greater than or equal to 5. And then we can later use it. So let's not get into too much detail here, but you're understanding what we are doing. You're providing a constraint. Constraint is check age, and check age is set to we check the age where age is greater than or equal to 5. We can later use it while altering the table or dropping the table. Okay. Use constraint to enforce critical rules in the database layer. Always name important constraint for easier maintenance. Prefer constraint over application side validation for core rules. Test check constraint carefully to ensure compatibility and enforcement in your MySQL server. Foreign key, we went through it. Folks, anywhere, any doubt which I went through, just let me know. We'll stop and get into depth. No doubts, right? Till now?
Yeah.
Okay. Foreign keys, we are good. Okay. There is an update cascade and delete on set null. So cascade works in a way, let's say if I'm deleting a related database, let's say if I'm deleting, do we have an example here? So cascade deletes all the child. Let's say there's a student, the student has multiple subjects. And if I do a cascade delete, the subject, the student will be deleted. And along with that, all the subject for that particular student also will be deleted. That is if you set the cascade is equal to true. And if it is set to false, it will remove the student from the student table. But in the subject table, the student ID will be set to null. Did you get it?
Yeah.
Okay. Devesh, did you get it?
Yes.
Okay, cool. Awesome. On delete cascade, delete the child rows when the parent row is deleted. On delete restrict prevents deletion if any child row restrict. On delete no action, same restrict in MySQL. Okay, this is just for okay. On delete set default, not supported MySQL, but available in some DBMS. Joins, we went through it. Okay, cross join, inner join, left join, right join. Union. Okay, so union, we get all the data that's we make a union all. These are certain MySQL specific function. You know, I want to select, you want to join the stream. This is how you use it. Okay. Select concat hello world as greeting. The output will give you hello world. So these are the operations that you can perform. Concat is one of them. Now we'll get you the date time. Length will get you the length of the string. Okay. You want to round to an integer. You use a round function. You find the date difference. Let's say you want to find a query. What would be the query? That something that was maybe that's a 15 days old, you know, something that was created 15 days before. So you can also use date, that is date dot now minus current column. Is it, if it is less than 15, then you show the output. Okay. Concat combines multiple string, length of the string, character length. It lowers the string, upper the string. There's a replace parameter where it replaces the values. The trim, it remove the trailing spaces. Now we'll give you the now, current date, current time, date, month name, year, day, date, round, floor, ceiling. Okay. I mean, we are not going to remember any of this, but just remember that there are certain functions available So while we are writing the query, make sure to take a look in the documentation, the official documentation. PostgreSQL may have different function, MySQL may have different function. So please do take a look at it. Then there are mathematical function, absolute, mod, random, if null. This is what is returns first non-value in the list. Okay. Poll as even I am not familiar what it is. Poll is. Okay, guys, are you familiar with this? Poll is null. Hello. Oh, it gives you the first empty value. Return the first non-null value in the list. There is a null, there is a not null value, and there is a string. So while you are making a query, it will return you the first non-null value in the string. Okay, got it, got it. Did you get it?
Yeah.
Okay, count will give you count number of rows, average, sum, min, max. We did all the problem. Then there is a view. Okay, a view in MySQL is like a virtual table. It does not store data by itself, but instead shows data from one or more table through a saved SQL query. As mentioned, you can use a view just like a regular table, select from it, filter it, and join. Okay, how do you create a view? What we are doing, create a view, public view as this query. This particular query is saved as view. Did you understand it? What I'm doing? There is a table, employees. I only want to create a separate table, which is a view, not a table. I don't want to insert into the table, but I want to put it in the memory. So there's a table view created out of this particular query. Did you get it?
Yeah.
Okay. Shall we do a demo on view?
Yes.
Cool. What do we have here? Select star from student. I think I have to select the database first. Used school DB. Done. Select star from student. Okay, this is the student. Now I want to create a view. Okay, create a view. Uh, what should be the view? Student with age greater than 18. Other student greater than 18, greater than 16. Yep. This view, student, adult student. No, all students are teenage. I mean, older students. Okay, create a view. How I want to create it? I want to select all the columns from student. And I want to do a where age greater than 15. Okay, I have created a view. Now, view is not a table, it's a view. So it is stored in memory. I mean, essentially, they are stored in memory, but you can get rid of the view. So we created a table out of a query. Select star from, what's the view name? Old student, right?
Old student.
We just created, right? Okay, refresh all. Older student, my bad. Yeah, we got all the students which are greater than 15. Cool. How do you use a view? You can use the view just like you're using the table. There is no such difference. Similarly, we can create or update or replace a view, and that's how you do it. If you want to make faster query, you create a view and then you run it. So now I want to drop a view. Drop view older student. Student. Done. Deleted. Views don't store data if the underlying table changes. The views reflect that automatically. Not all views are updatable. Simple views are usually like those selecting from one table without grouping or joins, but complex one may not allow insert, update, or delete. Get it? Views can make your queries cleaner and easier to maintain.
Hmm.
Okay, examples. Let's say you have to query this. I mean, as we did, like we would join the tables and every now and then in our previous exercises. We can simply create a view, store the data there, and we can make queries. Right? Divesh, are you following along? Hello, you there?
Yes, sir, I am there.
Like, click close button while I hit a switch tab. Cool. Devesh, are you there?
Yes, sir, I am.
Okay, cool. Any question, do let me know. And then, so what we are doing here, this is the query. Instead of repeating it, we just create a view out of it. And then now we can do the select star and we get all the queries. You're seeing it, right? This big query, we are creating a view and then we are making a query. So understanding the use case of view, right?
Yeah.
Okay. Then indexing. So indexing is data structure that makes data retrieval fast, especially when you're using where, join, order by, or searching large tables. Think of index like indexing a book. Instead of reading every page, MySQL use index to jump straight to the relevant rows. It speed up the queries, improve performance, enhance scalability of database uptime. Okay. How do you create an index? This is the function you create an index. Create index. You create an index email on where do you want to create an index? I'm creating an index on the email. So it is easily searchable. We can also create multi-column index, which is a composite index. Create index name city on name and city. This is how you do it. Similarly, you want to create anything on SQL, use create. You want to alter anything in the SQL, use alter. Let's say if it is a table related, it's column, then it is update. Want to delete it, use drop. Okay. Where do you want to use index? Let's say there's a table where a lot of on a particular column where you're making where clause, where join and order by clauses. There you should be using indexing. Okay, you're searching by unique fields like email, username, or ID. You're filtering large tables for specific values regular. See, in our case, it's a very small table. Indexing will not do anything. Anyways, this database are created in such a way behind the scenes that it's, I mean, unless and until it's a very large database, you will not see the difference. Okay, as you can see, there are no index. The index is only set to primary key. By default, primary keys are always indexed. Okay, when not to the table is small. Mhm. Column is rarely used in searching filter. You're indexing a column with a very few unique values like gender field. Okay, that you should not be used. You're inserting or updating very frequently. Indexing can slow down writing queries. Yes, yes, yes. Because indexing is done in a way. Uh, First, you have to write in the table, then you have to index it, so it will slow down your insert queries. So carefully, you have to use this indexing. Okay, let me. Okay, I want to see all the index from student. Okay, there's only one index, which is the primary key. Okay, can create index, delete index, and list index. We went through it. Then one of the more important topic in SQL, which is subquery. Okay, a subquery is a query nested inside an SQL query. It helps you perform complex filtering, calculation, or temporary data shaping by breaking down the logic into smaller steps. You can use subqueries in select, from, and where clause. Okay, imagine this as a view. What we are doing, we are writing a query, and inside query, we are writing another query. You're getting it. What I want to do, I want to get list of all the employees whose salary is more than average salary. So the way to do it is, this is one of the way to do it. You get a salary. Now, how we want this particular average salary value. Okay, so how do we do it? We get the average salary and then we write the query. So this is how we write a subquery. The name itself is very self-explanatory. A query inside a query, that's a subquery. Okay. Now, if I want to do a what do we subquery and from clause. Similarly, like imagine as if I were in this place, I would have created a view, so it's easier to read. And we are doing a select department and average salary. What we are doing, we are from a table that we have created already. This group by department salary, and then we are getting okay, where the average salary is greater than 50,000. You're getting it where we are writing subqueries. We are writing queries inside queries. so that we know like where from which table to configure. There is no such table, so we are creating a table by writing a query, like virtually creating a table, and then we are making our operations. Okay, we are telling SQL create a temporary table of average salaries by department, then filter department where the average is 50,000, greater than is above 50,000. Okay, any doubt in subqueries?
No.
No, right? Okay. Select name, select count stuff on projects where project employee ID is equal to employee.id is project count. Okay. We can also do a select on the, what do I say? So where we can write the subqueries, the more you write queries, you'll be familiar, like where exactly you can write subqueries, where you can use it. Okay. We can write in the select clause, from clause, and where clause. These are three places where we can write subqueries. A correlated queries depend on the outer query. It runs once for each query in outer query. So as you can see, the from executes first. Okay. Then there is a where statement that gets executed. So select average salary from employees where department is equal to E of department. Okay. We are telling for each employee, compare their salary with average salary of their department. Okay. So first, this query has to be executed. In our case, correlated, it runs once for each row in the outer query. Okay. In a correlated query, it's an employee. We're setting it as E of department. Okay. Sorry, from employees. There are multiple where. Okay. Depends on the outer query it runs. Okay. First, we are running this query. We're getting name, department, salary. And then again, this query is run. Okay. For each employee, compare the salary with the average salary of that department. Got it. So because the queries are interrelated, in all the cases they are interrelated. Okay, in this case, this will be only executed once, but in this case, they will be executed on every what do I say? Every time a result is fetched. Got it? Okay, because it is referring to outer query inside the subquery from getting E. We are doing an employee. So department is equal to your department. Any doubt here? Any confusion here in this part? There's a name, department, salary, employee. Now I want to compare the department of employees, whatever it is, the average salary department is equal to E dot department. Is it clear?
Yeah.
Okay. How is this an interrelated query? Now, when to use subqueries when your logic depends on calculated values like average or count, when you need to filter based on dynamic condition, when you're breaking down complex queries for readability. Okay. When the same result can be achieved with join, which is often faster. Okay, then you should avoid using subqueries. When subquery is being executed repeatedly for every row, correlate subqueries on large table. Okay, there you should avoid it. And we can run subqueries in where, from, and select. Group by, we went through group by, let's not go through it. There's only one topic pending, which is store procedure, and then we should be good. Okay, the with roller clause in is used by group by. So exactly. Group by having store procedure. A stored procedure is a saved block of SQL code that can execute later by calling its name. It's a function, okay? It allows you to group SQL statement and use them just like a function in programming. Let's go to an example. We are creating a stored procedure. This is how we create it. Okay. Create procedure list student in our case. It's a function. Function starts here. Okay, let's start from student in our case. And we are ending it. Okay. The delimiter is set to none. What is the problem here? I'm ending it, right? Oh, delimiter at the top. Delimiter spelling was wrong. Okay. Provider delimiter. This is the step to create procedure. This is a stored procedure. This is a function that we are creating, and all the logic that you want to specify it inside begin and end. Cool. And how do you call a stored procedure? Call list template. So what we're going to do thing is I have to throw the space probably. Yeah, I am creating a stored procedure which is called list students. Now I want to call it. How do I call it? Call list students because I misspelled it while I was typing it. And as you can see, so let's say if there are certain function you want to call again and again, this is how you do it. Okay. We can also specify stored procedure with a parameter. Think of it, it is like a function in SQL, and this is how you do it. Provide a delimiter. Okay. Then you do a create procedure, name of the procedure, and inside begin and end, you define your function. You guys want to give it a try at your desktop?
Yeah, we can, or it will be okay. Like we'll practice it.
Okay, let's do one thing. Do you have any table on your system, Chris?
No. Okay.
No, right? Okay. So that is it. That does sum up our lecture for today. And yeah, I did go through, I skimmed through it. So essentially, I'll share the handbook in the group and please go through it. And definitely practice is something that would be required. And one of the important concepts would be indexing. Like, okay, always think like when you would be using on a large databases, index is something that you can use. If you ever see that there are queries being repeated, you either put it as a view and then use it. There are multiple joins, there we are doing a single join, but there can be a scenario where you are making a join table that is also joined to other table. There can be multiple joins. So all those query writing it again and again, you either put it in store procedure, you put it in view, that would be good. You can also provide a function which is stored procedure, and going forward, you can reuse. Okay, any doubt anywhere so far? No, right? Okay, cool. I'll sum up the lecture today, and we have finished our SQL part. And from next lecture, we'll start with proper machine learning. This is going to be a mathematical lecture going forward. We will start our lecture with probability. So even I'll need time to prepare for that. So now my work has begun on that. Okay, cool. See you guys. Thank you for your time and have a good weekend. Yeah, bye.